Okay, so if we understand what factors of numbers are, things that divide evenly into a number, are factors of a number. What if I had something like x cubed? What are the factors of that? Does anybody have a guess? This is tricky if you've never seen it before, never thought about it. Can anybody think about? Uh-huh. Oh, the bottom one, yeah. Okay, very interesting idea. You're on the right track, but I'm going to show you one thing. So factors of a number are numbers that multiply to that. Or 2 times 2 times 3. That's called prime factorization. Not something we need to worry about, but it's a list of prime factors of 12. 2 times 2 times 3 gives you 12. Okay. If I applied that same idea to x, it would be x times x times x. So not 3, but 3 x's. Yes, because x times x times x is x cubed. This is a strange idea, but go with it. It's not actually that hard. But again, it's not something you can figure out on your own. So if you're not listening right now, you're going to be in you're not going to be able to do it. So then what would I do with x to the 7? Okay, so x times 2, 3, 4, 5, 6, 7. So I have 3x on top, 3x on the bottom. Very nice. So again, this is different. It's not hard, but it's different. Because we don't know what x is. If it was 12, it would be like, well, 3 and 4, and 2 and 6, and like you could come up with these things. But x is unknown. So the best we can do is the factors of x are x and x and x. So 3 x's. Wait, okay, Brianna first. Yeah, if you were asked to write out, which you won't usually have to write out the list. Like that's not what we're doing. We're kind of understanding why what we're going to do works. But yes, if you were asked to do this, you just write it out long. Yeah, Ethan?
So find the greatest common factor, wouldn't it? So it would be how many x's of the top variable and the bottom variable, or whatever you're...
The biggest and the smallest. That's exactly right. Very good. So what is common between the two? Well, that one, and that one. So 3. So not 3, not the number 3. The answer is x to the 3 is the greatest common factor. This makes it easy. If you have two variables, the greatest common factor between them is just like the variable 2, whatever the smallest exponent is. Because that's the most you can fit into everything. Okay, so it seems very simple, but again, it's very specific. You need to know this. You need to know it well. There's a lot of what we're going to do over the next 3 or 4 days will depend on this. Yes? Yeah. So let's try this first example. What about a squared and a cubed? Again, you do not have to list them out. The answer is very simple, but if all you do is take the shortcut and don't think about it, you're going to forget tomorrow what the answer is. So try to really think about it. I'm only going to do this once. So a squared is a times a. And a cubed is a times a times a. So what do they have in common? A squared. Is everybody okay with that? Okay, so here we go. This is where we really get into it. This is what you need to be able to do. And what the ultimate thing we're actually trying to do is even a little bit different from this. But this is what B, this example B right here, is very close to what we're doing and what we need to be able to do. How do I find the GCF of both? Well, first of all, I have to find the GCF of the number part, and then I find the GCF of the variable part, which we notice is fairly easy, and then you put them together. So what are all the factors of 3? Taylor? Oh, I thought you were putting it up. 1 and 3. What are the factors of 6? And if you did the activity, the practice, you might have some of these listed out. It's fine to sort of cheat and use that for now. Summer? 1, 2, 3, and 6. So what's the biggest? 3. And what's the biggest of the variable part? Ethan?
X.
Very nice. So the greatest common factor between 3x to the 4th and 6x squared is 3x squared. And by now, you might be asking yourself, what in the world? Who cares? Why are we doing this? Well, this is an algebra skill. It is a fundamental skill, super important. This is a huge part of mathematics. But it would be hard to see why and what its value is right now. But if you get this stuff and you work with it, in 3 or 4 weeks, you'd be able to start to see why. Okay. What about the next one? So again, like if imagine somebody who's not here today comes in and tries to sit down and write the learning goal tomorrow without having seen any of this. They would have no idea, right? They'd be like, I don't even know what it's asking. They wouldn't know where to start. Like, you need to have a plan in your head. What do I do first? I'm going to look at the numbers first, figure out the GCF between those two, and then I'm going to look at the variables, figure out the GCF between those two. And there are ones that will trip you up a little bit. So what's the GCF between 5 and 12? 1. So we don't have to write it. If you did, it wouldn't be wrong, but you don't have to write it. GCF. So 1, and then what about the x parts? X. So the GCF is x, 1x. 1x to the 1, or x. The way we like to write it is just x. Couple more trying yourself. And if you think this is like kind of easy or simple, it's not worth your time, it's going to get harder. And if you don't practice it while it's easy, then when it's harder, it'll be too hard. It's really, really, trust me, this is like a first step into a big new world. If you're going to take grade 11 college next year and possibly grade 12 college, or I know some of you have picked the mixed course, like you need to be really good at this. And the thing that we're starting on Wednesday, you need to really be good at it. This is like in grade 1 when you start adding. You've just started doing a new fundamental math skill, factoring. So what, does anybody have it for D? Go ahead, Brianna. 4a squared. And if I was going to check that answer, I'd ask, is there anything bigger that goes into 12 and 16? Anything bigger than 4? No. Like, oh, what about 6? No, 6 doesn't go into 16. What about 8? No, 8 doesn't go into 12, right? So it's got to go into both. And then a squared is the smallest exponent. So that's what we pick. Very good. Anybody have E? Four for the 12 and the 8. Awesome. Good question. Is there an X or not? So my question is, like, is there an x common in both terms? There isn't, so let's take the x out. Good, but that's, again, why we do these different kinds of examples. It's not obvious, okay? So if there's an x in one of them, but not an x in another, no x, or whatever variable it is. What if you're looking at like 3 terms? Then whatever's in it has to be in all of them. Any questions?